Today we are going to do proofs. So we've learned the theorems for the parallelogram. So we're going to now prove that either something is a parallelogram or use what we know about parallelograms to prove other things. So we have three examples here. So our first example, you're never going to have to do one of these by scratch. So you'll always have at least either half of it, like one side filled in, the statements or the reasons, or you will have both sides filled in and you'll just have to fill in the pieces. So they're normal proofs. So what we start off with is that we have a parallelogram. So ABCD is a parallelogram. So I'm still starting with my given. Then from there, I have to use what I know about parallelograms. And since we're trying to prove that AB is congruent to CD and BC is congruent to DA, I'm trying to prove that the sides are congruent. So in order to do that, what I first have to do is I have to say that the triangles are congruent. So in order to do that, we have to get our three things congruent, and then we have to say the triangles are congruent, and then we can say the corresponding parts are congruent. So our next step, what we know about a parallelogram is that AB is parallel to CD, and that BC is parallel to AD, and that's just the definition of a parallelogram. That's what it means. If we go back to our vocabulary word for a parallelogram, it says that it has two pairs of parallel sides. From there, we can say that angle 1 is congruent to angle 4, so I'm going to label my picture, and then angle 3 is congruent to angle 2, and that is because we have alternate interior angles. So remember, anytime we have parallel lines in a proof, that next step is always going to be alternate interior angles. And since I'm trying to prove triangles are congruent, I only have two things. I still need one more, so I'm going to look at my picture now. And I'm going to say that AC is congruent to AC. And when something's congruent to itself, that is called the reflexive property. So from there, we can say that triangle ABC is congruent to triangle DCA, and that is by angle side angle. And once we have triangles are congruent, we can say that their corresponding parts are congruent, and that is by CPC/TC. So we used what we knew about a parallelogram to show that the triangles were congruent, so we could say that their sides were congruent. And most likely that's the route you're going to take with these. This next one is a little bit different. So what we're trying to prove is that angle A and angle C are congruent or equal, and angle B is equal to angle D, which we already do know that just because of our theorems, but we are going to try and prove it. So for number 1, we're going to start with ABCD as a parallelogram, so that's our given. So we're given those parallel sides. And what we do know is that the consecutive angles, so angle A, angle B, and B and C, those are supplementary. So that's just because the definition of a parallelogram, again, tells us that those angles are supplementary. So from that step, since they're both equal to 180, what I'm going to do is I'm going to take BC and I'm going to plug it in for 180, and that's what gives me step 3. Angle A plus angle B equals angle B plus angle C. So when I plug something in for something else, that's called substitution. Then if I subtract angle B from both sides, they're going to cancel out. And so that's going to give me A is equal to C. So I already have one part in my proof right here. So this isn't going to be all of the last step. So I proved one, now I have to prove the other, and I'm going to go the same route. So I know that BC plus C equals 180, and then also C plus D equals 180. And again, that's the definition of a parallelogram. We know that the consecutive angles are supplementary. Then from there, I'm going to take C plus D, plug it in for 180 because they're equal. So I can plug something in that's equal, and that is called substitution. And then lastly, I'm going to subtract C from both sides, which they will cancel out. So subtraction, and then that will give me my B equals angle D. And so I have proved my two things. Now this next one is a little bit backwards. So we're not given the parallelogram. We're trying to prove that it's a parallelogram. So this we really have to think about all of our properties that go along with parallelograms. So for my first step, I'm going to start with my given. So no surprise there, still the given. Now I know that triangles are congruent, so that tells me that the corresponding parts are congruent. So CP, CTC. So what I can say is that AD is congruent to BC, and that's by CP, CTC. And I can also say that DC is congruent to AB. And again, I can say that because these triangles are congruent. So if I look at my triangle, I've got AD congruent to CB, and I've got DC congruent to AB. And so with that, now I have a parallelogram because my reasoning is I know that if both pairs of opposite sides are congruent, that makes a parallelogram.